this video, we're going to talk about graphing logarithmic functions. So let's graph a real basic one. F of x is equal to log base 2 of x. We want to write the domain and range in interval notation. So we know this. And we can rewrite this as 2 to the y is equal to x. Nothing more than an exponential. So let's create a table. I'm going to pick y values because it's already solved for x. So 2 to the negative second is the same thing as 1 over 2 squared, which is 1/4. 2 to the negative first is the same thing as 1 divided by 2 to the first. That's 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. All right, so let's plot these 5 points then. All right, so what do we know? We know for sure the domain, 0 to infinity, and the range is all real numbers. Now, what else can we determine from this? We know the x-intercept is 1, which is the same thing as 1, 0. There's no y-intercept. Okay. We know because of that there's a vertical asymptote at x equals 0. This is certainly a one-to-one function, and it is increasing from 0 to infinity. Okay, now what happens if we change the base to, let's say, 1/2? How is that graph going to be different? Now again, you know for sure that we can rewrite this as this. So again, I'm going to create a table for this. Okay, so -2, -1, 0, 1, and 2. Okay. So 1/2 to the negative second is the same thing as 2 squared, which is 4. 1/2 to the negative first is the same thing as 2 to the first, which is 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2, and 1/2 squared, which is 1/2 times 1/2 is 1/4. Okay. All right, so let's plot these. Okay. So again, well, what do we notice here? The domain is still 0 to infinity. We know the range is -infinity to infinity. That has not changed from the previous example. X-intercept is still at 1. There's no y-intercept. Vertical asymptote is still at x equal to 0. And it's a one-to-one function. But you do notice now it is decreasing from 0 to infinity. Now, before we move on, I did want to show one quick thing on Desmos. Now, you remember what log base 2 of x looks like, right? That's in red. You can see the graph here. And 2 to the x, which is in blue. Okay? Notice they are symmetrical because they are symmetrical across the identity axis, which is f of x is equal to x. So, log base 1/2 of x and 1/2 to the x power would also be inverses of each other. Okay, so now I want to graph logarithmic functions by transformations. Okay? We want to make sure the original has 3 points and then write the domain and range of the final transform function in interval notation. So what I've already done here is gotten us our 3 points. So now I want to write in order of the transformations. Well, we're going to start with log base 2 of x plus 1. That's telling me I'm going to go to the left 1. Okay. My next transformation, okay, would be the negative that's inside. So that's going to reflect across the y or f of x axes. And then our last one is the minus 3. Which tells me I'm going to go down 3. Okay, so now the first thing I want to do is to graph the original. Let me plot those 3 points. All right, so now then I want to go to the left one. Okay. So now I want to reflect across the y or f of x axes. Okay. So that would be here. This point in blue would not change, and this would be over to here. Okay. So I can go down like this and then up as such. Okay. And then from the red, I want to be able to go down 3. Okay. So then from there, the final transform function, I should be able to write the domain. Well, the domain here is from negative infinity to 1. Okay. And my range is negative infinity to infinity. Okay, one other example I would like to take a look at then. Okay. Okay, so as you can see here, I have already done the first part. So again, all I want to be able to do from this stage is to write out the transformations in order and then be able to graph. So let's do this. So that's telling me I'm going to go to the right 3. The next one is going to be the negative, which that will reflect across the x-axis. And then I got to add the 2. Okay, so first of all, I will graph the original. I'm going to scroll this down a little bit. All right, so now I'm going to go to the right 3. All right, so now I'm going to reflect across the x-axis. So that'll be here and here and here. And then finally, I'm going to go up 2 from the red. Okay, so for the final black transformed function then, I should be able to identify what the domain and the range is going to be. So then the domain will be 3 to infinity, and the range is negative infinity to positive infinity.